Here we're looking at example 3a from our 1.5 notes. We're asked to evaluate the following limit, and as we can see in this function, everything is already gone ahead and factored for us. Unfortunately, nothing can go ahead and cancel. Now, as always, we want to go ahead and start out by looking for these vertical asymptotes, so we're going to do that by setting the bottom not equal to 0. So then it looks like when we use that zero product property, set each one equal to or not equal to 0, we end up with that vertical asymptote happening at 3 and the other one happening at -2. So there is in fact a vertical asymptote happening at these two places, and if we look carefully we see that we have the limit as x approaches -2. So in other words, we are approaching a vertical asymptote here. So now let's go ahead and look at these limits one-sidedly. We have then the limit as x approaches -2 from the right side of our function x plus 1 over x minus 3 times x plus 2. Again, we're trying to see if that method works for our one-sided limits by going ahead and plugging in values and just kind of looking at the signs of these. So if we were to choose something that's to the right side of this, -2, maybe like the value, we'll just go with 0. If you threw 0 in here, we'd end up with a positive over a negative times a positive. So on the bottom we would end up then with a positive divided by negative times a positive is a negative. We see that we have a positive divided by a negative, so we would think that we would end up with a negative, and as it's approaching this vertical asymptote, infinity. Now let's go ahead though and choose a number. Instead of 0, let's choose something a little bit closer to -2. If we were to choose, say, like -1.5, so something a lot closer to -2, well, then we would end up with a negative on top divided by a negative, and then -1.5 plus 2 comes out to be positive 0.5, but it's a positive. Negative times a positive is a negative, and we still have this negative on top. So now as we actually approach -2 from the right side, we have a negative divided by a negative, which comes out to be actually a positive infinity. So the moral of this is to actually try and choose x values that are closer to your vertical asymptote. Alright, so this one over here, when we chose 0, that's actually not a very good approximation for kind of the behavior as it's approaching that VA. Here is the graph of that. You can even see at 0 we have that negative value, whereas when we chose like -1.5, we can see it's approaching that positive infinity as you keep going closer and closer to that VA. So again, just choose x values that are really, really close to your vertical asymptotes, because otherwise they could be a little misleading. Now if we look then at the limit as x approaches -2 from the left side of our function, let's again choose something that's really, really close to -2 from the left side. So maybe like -2.5. When we throw that in there, we end up with a negative on top over a negative from here and a negative from here. Negative times a negative gives us a positive. We'd end up with a positive on the bottom. So a negative now divided by a positive comes out to be a negative. So we should end up, as you get closer and closer to that vertical asymptote, you should end up going toward negative infinity. So again, since these do not match, this limit just would not exist. So in conclusion, there is an asymptote at x equals -2, and because our one-sided limits do not match, then the limit as x approaches -2 over all of that function, x plus 1 divided by x minus 3 times x plus 2, is simply not going to exist. And again, just because they ended up going to two different places. So again, though, that is example 3A from our 1.5 set of notes.